Let me do some tutorials to find the directional derivatives. Find the directional derivative of phi equals to xy square plus z square at point P 2, minus 1, minus 1 in the direction of vector 2i plus j plus 4k. 2i plus j plus 4k is the unit vector. Solution. Phi has been given, which is xy square plus z square, and the first thing that I'm gonna do is to find the gradient. The formula of the gradient is I partial phi or partial x plus j partial phi or partial y plus k partial phi or partial z. Substitute the value of phi, which is here xy square plus z square. Just substitute this value for the phi here and then take their derivatives. The derivative of this term with respect to x is y square, and derivative of this term with respect to y is 2xy. Derivative of this term with respect to z is 2z. Substitute the value of the points where x is 2. Just substitute the value of 2 for the x variable. And point y is minus 1. Substitute the value of minus 1 for the y variable. Z is minus 1. Substitute minus 1 for the z variable. Solve it further. P is actually xyz points, which are 2, minus 1, minus 1. This is the value of the gradient. Now to find the directional derivative. The formula of the directional derivative is here. Dot product of gradient and unit normal vector per magnitude of the unit normal vector. We have already achieved the gradient value, which is I minus 4, which is I minus 4j minus 2k. Just substitute this value for the gradient here. And the value of n is here, which is 2i plus j plus 4k. This is the unit vector. Substitute this value here for the n per magnitude of the same n. Substitute all the values, solve it further to have 2 minus 4 minus 8 over 21 under the root. I took the product of I times 2i, where I times I equals to 1, so I got 2 here. I took the product of minus 4j times j, where j times j equals to 1. I got minus 4. I took the product of minus 2k times 4k, k times k equals to 1, and I got minus 8. Solve it further. This is my final value for the directional derivative, minus 10 over 21 under the root, which is in a scalar form.